The random variable x is binomially distributed with n being 12 and the probability of success being 3/5. Using the cumulative distribution function, find a, the probability that x is between 5 and less than or equal to 8, the probability that x is equal to 10, and the probability that x is greater than 9. So we've got x binomially distributed, n to 12, p, the probability of success is 3/5. The probability that x is more than 5 but less than or equal to 8, we need to think about the probability of being between 6 and 8, less than or equal to 6 or less than or equal to 8. If we go to a GeoGebra and go to view and get the probability calculator and set here to 12 and this to 0.6, which is 3/5. In the first case we want 6 and 8, okay, which is already in, so we'll just write those in here. If this, you can't see this, you need to just raise it from the bottom. Normally you can't see it on a Mac. Okay, so we want this area here, and that means adding together those three probabilities there. If we go to the cumulative distribution function, then what we're going to need to do is take that one and then subtract from it that one. Okay, and it might actually be better if you look at this one. Let's just set that up again. 6 and 8. Okay, because what you're going to do is you're going to take all of those and then subtract those. Okay, so using the PDF, we would have to add together these three probabilities, these three here. Using the CDF, the probability of being between 5 and less than or equal to 8, we need to take the probability of x being less than or equal to 8, which is that one there, and then subtract from it the probability that x is less than or equal to 5. So what we're doing is taking all of that area and then subtracting that area and get the area which is left, which gives you 0.7747 minus 0.1582, which gives you 0.6165, which is 0.617 to 3 decimal places, 3 significant figures, sorry. Now you might get a slight discrepancy in the last figure because these have been rounded off to 4 decimal places. Second one, probability of x being equal to 10. Well, if we set this up in here and do on this by putting in 10 and 10, sorry, it stayed at 6, so just put 10 in again, enter. Okay, all we want is that rectangle there, which is that, in fact, that is the actual answer there, the one that's been shaded. Okay, how do we do it with the community distribution function? It's a little bit more difficult. What we need to do is do less than 10, take away less than 9. So we get less than 10 from there, and then we need to subtract less than 9 from there. Okay, so using the PDF, in fact that's actually the answer, that's probably the easiest way to do it in fact, but if you had to use the CDF tables, then the probability of x being equal to 10 will be the probability that x is less than 10 minus the probability that x is less than or equal to 9, so that's that one, take that one, which is 0.9804 minus 0.9166, which gives me 0.0638. Again, you're going to get a slight discrepancy on the last decimal place due to rounding. Okay, in the last case, x is binomially distributed 12, 3/5. What probability that x is greater than 9? That's probability that x is greater or equal to 10. So we're going back to this again. If we go back to the binomial, more than, and if we put 10 in, that's what we want, that's the area is what we want. Okay, how are we going to use CDF? We're going to go from 1, because all the areas up to there will be equal to 1, minus the probability x is less than or equal to 9, which is that one there. Okay, you can get the probability table from here. So you need to do 1 minus this one here. So using the PDF, you do that. So you doesn't need to sum those probabilities. Using the CDF, then we're going to do the probability that x is greater than 9 is going to be 1 minus the probability that x is less than or equal to 9. So that's all of that area, 1 minus all of the area which has not been shaded. From the tables, you need to do 1 minus this value here, and it'll give you 0.0834 to 3 significant figures. Okay, this has been a video to show you how to use the cumulative distribution function to find binomial probabilities. Very good tool for getting the CDF tables, cumulative distribution tables, using GAlgebra app as shown in the video. I hope you've understood, and I thank you very much for watching.